Welcome to Music Explored. I'm your host, David Rivas, and today we're going to take a look at the most fundamental aspect of music, time. Time is the core of what we do in music. If we don't have time, we don't have music. As with many other forms of art, there's a progression that takes place in music, leading from one point to another towards a climax that's informed by what took place previously. Moreover, music is a presentational art form. Like dance or theater, the production of music culminates in a live performance. Modern technology allows for the distribution of recordings. However, the essence of sharing music is still live. This allows for subtle or even significant differences in subsequent performances of the same piece of music, even when the same performers are featured. Another reason that time is so important is that mistakes in time are more noticeable than others. Play a wrong note, and you might get away with it. But play with the wrong counting, or worse, stop playing altogether, and you risk losing the engagement of your audience. Even our idea of pitch is bound up in time. Pitch is the idea of higher versus lower notes. The higher the frequency, the higher the pitch, and vice versa. But frequency is the number of oscillations in the sound wave per second. In other words, we need time to have pitch itself. This all leads us to our topic for today, rhythm. Rhythm is the combination of various notes or tones and rests or silences. Some units of time are absolute. Minutes and seconds continue for the same value. That is, unless you're really into relativity. In contrast, musicians count the various lengths of notes and rests in relative terms. We maintain their ratio to each other, but their speed can change. Faster speeds mean shorter notes. Slower speeds mean longer notes. In either case, the ratio remains consistent. To go further, we need to talk about some terms. The most basic of rhythm terms is a beat. Now this is different than the kind of beat where we say, hey, that song has a really sick beat. Although that's awesome when that does happen. This kind of beat is a regularly recurring pulse. We feel this pulse as a framework for everything else going on. Every note we play or rest we leave silent relates to these beats. The speed of those beats is driven by tempo, or the length of time it takes to get from one beat to another. We use a couple of interconnected but distinct systems to indicate our tempo. The older method is more general, telling us to be fast or slow, dragging or moving frenetically. When musicians use this system, we often use Italian terms such as allegro, which means fast, or adagio, which means slow. A lot of our musical terms come from Italian. This is because during the Renaissance, Italy was a significant part of the development of Western music, and so we've continued using a lot of those terms ever since. Another system that's developed over the past couple of hundred years is the metronome marking system, which shows the beats per minute in numbers. Some of these numbers are easier to count than others. Intervals of 60 are easy to compare to the number of beats per second. Other numbers are harder to count without the aid of a metronome. 1 beat per second might be simple, but 155 might not come to you right away when you need it. Eventually, you can get to the point where you don't need a metronome to show you an exact count, because you can remember it quickly on your own. However, getting there usually means hundreds of hours of practice with a metronome. So your teacher was right. You need a metronome. With beats and a metronome, we can count pretty consistently at a given tempo. However, if all our beats sound the same, it can be hard to keep our place in the music or to communicate that place with other musicians or the audience. We need a way to clearly and easily define where we are. This imperative led to the development of meter in music during the Middle Ages. A meter is a collection of beats characterized by accents. This comes out of poetry's qualitative meter, which has regular stressed and unstressed syllables at particular intervals. Similarly, the musical meters have regular patterns of stressed and unstressed beats. These patterns help to define the feel of the music we hear. The first beat in any meter is the strongest by default. Some meters have several accented beats, while others stick with just the first beat. If we can identify the pattern of accents, that'll tell us what meter we're in and where we are in it. because the pattern is consistent for each meter. A meter will continue throughout a piece of music, repeating constantly. As one repetition ends, the next begins without delay. One repetition is called a measure. This is where the music happens. The measures are separated by vertical bar lines, which show us the beginnings and endings of each measure. Don't let the presence of a line make you think you should stop. You should keep going. It's like when you're driving down the road and you see mile markers on the side. Don't stop. Keep going. The mile markers are there to show you how far you are along that particular road. Similarly, the bar lines are there to show you how far you are into that piece of music. Many pieces of music include measure numbers at the beginning of each line to help you know where you are, which is really handy if you're 200 measures into a piece of music and suddenly you're wondering if you've counted them correctly. There are several different types of meter, each one with multiple different beat patterns. However, before we get to those in detail, we should take a look at some different types of beats and effects on those beats. A word you may have heard before is the downbeat. This comes from the conducting gesture of moving the hand down to start a new measure. So the downbeat is always the first beat of a measure, which again is the strongest beat. Conversely, the last beat of a measure is called the upbeat, also from conducting. The last motion before starting a new measure is to go up in anticipation. So the last beat of a measure is called the upbeat. Another term which has a pretty big impact on meter is syncopation. This happens when either a strong note falls on a weak beat, or when a strong note falls off the beat entirely. In either case, the feel of where you are in the meter has changed. This could be for a single note or for an extended passage. Sometimes composers add accent marks on syncopated notes to show their importance. At other times, just where in the measure you place a weighty note or chord demands a feeling of syncopation. Finally, we have a pickup, a partial measure borrowed from the last measure of the piece. This takes place in the beginning of the music and gives the impression of joining the idea midstream rather than at the beginning. Interestingly, this usually continues throughout the piece, so new phrases begin before the downbeat. Now that we have a structure in place, let's get specific. We learn about the exact kind of meter from the time signature, a number symbol at the beginning of a piece that shows us what specific meter we're in. There are two numbers, one stacked on top of the other. The top number shows us how many beats there are in this particular meter. The bottom number shows us which type of note gets a single beat. This brings us to specific types of notes. We use graphical symbols to represent the different lengths. They vary depending on their type, but all of them revolve around the note head. The note head is an oval, which can be either hollow or filled in, depending on the length of the note. We place them on the music score to show when and what to play. Each length of note has a corresponding symbol for rests. The longest note in most modern music is the whole note, represented by a hollow oval. Next, we have a half note, worth half the value of the whole, or 2 beats. We add a vertical line to the note head called a stem, on the right side if it goes up, and on the left if it goes down. Next is the quarter note, worth a quarter of the whole, or 1 beat. To get this symbol, we fill in the note head. Next is the eighth, which is half the quarter. Here we add a flag to the right of the stem. For the rest of the note values, we add flags one at a time to show the decrease in length. Notice the pattern? Every time you double the number, you cut the length of the note in half. This might seem counterintuitive until you think back on your lessons in fractions. Think about a pie. A whole pie is 1/1. Half a pie is 1/2. A quarter pie is 1/4, and so on. This is how we express musical note values. So the larger the note, the shorter the length. Now I want pie. Now at long last, we'll finally talk about the types and examples of meter. We'll start with simple meters, which I'll explain using the most common of all meters in Western music, 4/4. 4 beats to the measure, and the quarter note gets 1 beat. The downbeat is on 1, the upbeat is on 4, and there's a moderately strong beat on beat 3 as well. 2 is simply a weak beat in this meter. The balance in this meter adds to its popularity. It's steady, with even number groupings, so it's easy to hear where you are and feel where you can participate. And like all the other simple meters, 4/4 divides evenly underneath the beat. So the quarter note divides into 2/8, the eighths into 2/16, and so forth. Other examples of simple meter are 3/4, 2/4, and 2/2. The last of those has the half note as its beat note instead of the quarter note. Another type is compound meter. This happens when the top number is a multiple of 3. We accent every third note in the measure, leaving the beats in the middle feeling unlike beats at all. The effect is to divide up the beat into groups of 3, whereas in simple meter we divide up the beat into groups of 2. Some example compound meters are 6/8, 9/4, and 12/8. Notice that many of these have a lower number of 8, which shows us that the 8th note gets 1 beat. The compound 3 gives a feeling of movement throughout the entire piece. Finally, we have our wildcards. Anytime a meter's top number is a prime number greater than 3, it's asymmetric. So 5/8, 7/4, 11/2, they're all asymmetric meters. All of the other types of meters are based on groups of 2 or 3, so it's easier to count. Think 2 plus 2, or 3 plus 3 plus 3. You get into a groove. But in asymmetric meters, you have to count in mixed groupings, such as 2 plus 3, or 3 plus 2 plus 2. This is just more challenging, both for the audience and for the musicians performing, and so you don't see these as often in Western music. But they are on the rise. Think of Gustav Holst's Mars from the Planets, Dave Brubeck's Take 5, or even the bridge from the Beatles' Here Comes the Sun. Asymmetric meters are also more common in the music from other cultures, such as in Eastern Europe and Asia. We've covered a lot of ground today. Hopefully this demystifies some of the processes and terms of music and helps you better understand what you hear, see, and do. If something from today's video still doesn't make sense, please leave a question in the comments below, and I'll get back to you as soon as I can. If you're curious to learn more, subscribe to our YouTube channel to be notified of upcoming videos as soon as they drop, and like our page on Facebook for production updates and news about the channel. Thanks for watching, everybody. And as always, keep exploring.